Waveform distortion is defined by IEEE 1159-2009 as a steady-state deviation from an ideal power frequency sinusoid, principally characterized by the spectral content of the deviation. IEEE 1159 lists 5 primary types of waveform distortion. The first and most deliberated type of distortion to be discussed is harmonics. Harmonics are sinusoidal voltages and currents having frequencies that are integer multiples of the fundamental frequency. When these harmonic frequencies are added to the fundamental voltage or current, a distorted waveform is produced. This first figure illustrates a distorted signal with a fundamental frequency of 60 Hz. If the spectral content of the signal is analyzed, it is apparent that the distorted signal is a combination of a 60 Hz signal and a 300 Hz signal. This 300 Hz signal is commonly referred to as the fifth harmonic of the fundamental signal because its frequency is 5 times the fundamental signal. A single quality, called total harmonic distortion, or THD, is used as a measure of the magnitude of the total distortion across the harmonic spectrum with respect to the fundamental frequency. Harmonic distortion is generally caused by the nonlinear characteristics of devices and loads on the power system. As loads such as power electronics-based equipment consume currents in a nonlinear fashion, a nonlinear voltage drop also occurs across the system impedance. It is important to account for the magnitude of the distortion, not just the percentage of distortion. IEEE Standard 519 is a good reference for understanding harmonic distortion limits on a power system. Interharmonics are voltages or currents having frequency components that are not integer multiples of the fundamental frequency. They may appear as discrete frequencies or as a wideband spectrum. Interharmonics can be found in systems of all voltage classes and may be the result of various types of loads, including induction furnaces, arcing devices, cycloconverters, and static frequency converters. Interharmonics can impact the operation of some equipment depending on the frequency components present. This slide illustrates a fundamental frequency signal with a superimposed interharmonic frequency component. Notching is a periodic voltage disturbance caused by the normal operation of power electronic devices when current is commutated from one phase to another. Because of a notch's characteristics, it could be considered both as a distortion and as a transient. However, unlike transients, notches are steady-state phenomena that exhibit high-frequency content. Three-phase converters that generate continuous DC output are the most significant source of voltage notching. Operating multiple three-phase converters in the absence of filtering can produce waveforms similar to the one shown. Noise is unwanted steady-state electrical signals with broadband spectral content superimposed upon the power system voltage or current in the phase conductors, or unwanted electrical signals found on the neutral conductors or signal lines. Noise essentially consists of any unwanted distortion of the power signal that cannot be classified as harmonic distortion or transients. There are a number of loads that can produce noise, including power electronic devices, control circuits, arcing equipment, loads with solid-state rectifiers, and switching power supplies. Improper grounding can often exacerbate noise issues. Typical magnitude of noise is less than 1% of the fundamental voltage signal's magnitude. While noise can disrupt the operation of electronic devices, it is possible to mitigate noise issues with various filtering techniques. That was a brief discussion on waveform distortion. Back to you, Carl.
Thanks, John. Be sure to watch the whole series to learn more about power quality phenomenon. This is Carl Kersey from Carl's Corner. Be safe.